Hello again, this is continuation of the last lesson where we looked at verification of Ohm's law. Okay, so I showed you that we could verify Ohm's law using a method where we have a battery and we connect an ammeter and we connect a resistor of unknown resistance, and across this resistor we are going to require a voltmeter to measure a potential difference of voltage, and in series with a resistor R we're going to have to connect a rheostat. Okay, and of course we are going to need a switch. Okay, this switch is going to be opened each time we take a reading to control the temperature. So because remember we said we do not want the temperature to change, because according to Ohm's law, okay, the potential difference is going to be proportional to the current passing through this resistor here, provided the temperature remains constant. Okay, so this is the setup we discussed in the previous lesson. As for the results that we are going to record, we record the current in amps and the voltage in volt. Okay, so and for the graph that we can plot, we are going to plot a current in amps here, and on the vertical axis voltage in volt. And the graph, we discussed that it looks like this, and the graph passes through the origin. So this is change in current and this is change in volt. And we also discussed that the gradient, okay, is equal to change in volt divided by change in current. Okay, and because this is voltage divided by current, the gradient is equal to resistance. That's what we discussed in the previous lesson. Okay, but this is method 1. Think of it as method 1. There is method 2. So an alternative way of doing this. So what can we do? Let's say we do not have this component. Okay, this one, we do not have a variable resistor or rheostat. So what can we do? Instead of changing the current, we can change the voltage. So we will keep on increasing the voltage of the battery by adding more each time we take a set of results. We are going to be increasing the voltage of the battery. So let's say available to us, we have 4 cells, right, each a 1.5 volt. Okay, so if we start with just one cell and we connect an ammeter and we connect a resistor, think of this resistor as resistor of unknown resistance. Okay, in this case we are not going to connect any rheostat, so but we are still going to have our switch, and we close this circuit. So if we had connected a voltmeter here across this resistor, we can now immediately record 2 readings. Okay, so we can immediately now record 2 readings. So what are we going to record? We are going to record voltage in volt, and we are going to record current in amps. In this case, notice that I am going to be changing the voltage. So this is going to be let's say this is let me add another column here, and this one is going to be trial. So for trial 1, the voltage is going to be 1,5 volt. For trial 2, okay, let me draw the circuits that can be used for trial 2. I'm going to instead of using just one cell, I'm going to have a battery now with 2 cells connected in series. Okay, but I'm going to keep the same resistor and have the same voltmeter connected across the resistor. And I now have a switch again, right? And the circuit is complete. For trial 2, it means this one is going to be 3. Okay, so if I now, for trial number 3, I will have another circuit, but I hope you get the idea. I'm not going to draw that one. If I add, if now I'm now going to be using a battery with 3 cells connected in series. So this will increase the voltage to 4,5 volt. For the 4th trial, this is going to increase the voltage to to 6 volt. But each time I'm going to be recording the current here. So what do you think is going to happen to the current? Okay, so the current, maybe if the current is going to increase with, we can now predict what's going to happen with the current because they are directly proportional. Our prediction is that if we increase the voltage, the current is going to increase as well. So meaning if we measured 2 here, 2 amps for the current, then here it's going to be 4, then here it could be 6, and then here it could be 8. Okay, so now if we plot this graph now, okay, we are going to plot the current. So sorry, not the current now. We are going to plot the voltage in volts here because the voltage is what I was changing. Remember, the physical quantity that you change is referred to as independent variable. So here I was changing the voltage. So that means I'll plot the voltage on the horizontal axis, and the current in amps is what I was measuring using the ammeter immediately after changing the voltage. So the current is going to be plotted here as the dependent variable. I'm still going to get a graph like this, which is a straight line. Okay, so if I calculate the gradient now here, this is going to be change in what is in the vertical axis. I have change in current. Okay, on the horizontal axis, I have change in voltage. So the gradient of the line is going to be change in current divided by change in voltage. So what is this now? So when I had change in voltage here in the numerator and current in the denominator, I called that resistance. Now notice that here I have current at the top as the numerator and then change in voltage at the bottom. Okay, so if this one is resistance, what do you think we are saying? We are saying resistance is equals to change in volt divided by change in current. But notice that this is over 1. So if I invert this one to change in current divided by change in voltage, I must also do the same on the left. So this is going to be 1 over resistance. Okay, so which means 1 over resistance is just going to be 1 over R. So 1 over R is change in a current divided by change in volt. Right, so this is exactly what I have here. Here the gradient, I'm saying the gradient is change in current divided by change in voltage. So what is this equals to? This is 1 over R equals to a change in a current divided by change in voltage. So we are now going to discuss what is 1 over r. This is the inverse. Okay, this is the inverse of resistance. So what is the inverse of resistance? Think of it like this. If a conductor has a very high resistance, it means the conductivity of that conductor is very low. If a conductor has very high resistance, the conductivity of that conductor is very low. Okay, so now this quantity 1 over r represents conductivity. This is conductivity, right? Okay, so this one is resistance. So what is the unit of conductivity? This is going to be measured in per ohms. So you still write ohms, but you write a exponent -1 there. Okay, so now let's look at this question. So learners investigate the conducting ability. They are investigating the conducting ability of two metals, metal P and metal Q, made up of different materials. They connect one wire at a time in a circuit as shown below, right? So the potential difference across each wire is increased in equal increments. So out of the two methods I showed you, which one are the learners using? Because now they are saying the potential difference is increased in equal increments. They are using the second method. There is no variable resistor here. So it means for, let's say we were looking at wire Q. Okay, so there is wire Q here. So what you will do, you will set up those circuits, okay, beginning with the smallest voltage, and you will have wire Q, right? This is wire Q, and you will connect a voltage here, and you have a switch. Remember, you must open the switch between the readings. Okay, switch S. When you close this, you will have a reading. So you record your table first, okay, and you would record voltage in volt, current in amps. Okay, you will have your trials. So trial 1, 2, 3. Okay, so you could have 1,5 volt, 3 volt, 4,5 volt, 6 volt, etc. Then you will record your current, the reading of the ammeter. Once we have done that, you will plot this and produce this graph for wire Q. Okay, once you are done for wire Q, you would then change the wire. Repeat the same process. Now change the wire and use wire P. This is wire Q. You'll plot the same table, okay? The same table now, but for wire Q. So you'll have V in volt, remember, and you will have a trial. So you will have trial 1, and because you start with one cell, you should have 1,5. But for trial number 2, according to the statement, we increase the voltage in equal increments. So this is going to be 3. Okay, so it means you must connect there another cell. So you must have 2 cells to have 3 volts. Okay, and then for trial 3, 4,5. For trial 4, 6. But each time you must record the reading on the ammeter here. Okay, the ammeter is going to give you the current. And then you'll also plot, this is YP. You'll also plot another line. Okay, according to the question, when we did that, we got this line and this line for wire P. Okay, so now there are questions based on this. We need to answer those questions. Okay, 11,1, it says name 2 variables that the learners would have controlled in each of the experiments. So what are those variables? So the first one is the one that I keep on mentioning. So I'm saying when you do trial 1, before you can do trial number 2, you must open that switch so that the temperature remains constant. So that means you want to control the temperature. Okay, number 2, the second thing that you want to make sure in each time you do trial 1 and do trial 2, you are going to keep the thickness of the wire the same. Okay, so you want to make sure the thickness of the wire is same. Right, or you could have said area of the conductor, or the area of the wire, that would be accepted as well. Okay, so 11,2. So which one, P or Q, is a better conductor? Explain your answer. Let's go and look at the graphs given. So remember, let's look at what is on the vertical axis. We have current. And what is on the horizontal axis? We have potential difference. If we do the gradient, here the gradient of any line, either Q or P, is going to be change in what is on the vertical axis. That is going to be change in current, divided by change on what is on the horizontal axis. That's going to be change in voltage. So what physical quantity is represented by this one? Okay, remember, you are going to be, it's not difficult to figure this one out, because on your data sheet you are going to be given the formula R equals to V over I. Remember that formula. It means if you have voltage in the numerator and current in the denominator, that is equal to resistance. But here it is inverted. Okay, so you have the opposite, the inverse of resistance here, because you have, instead of, this is not, definitely not resistance. If it's not resistance, it is conductivity. Okay, so the gradient represents conductivity. So looking at the graphs, so because a wire Q is steeper, the line, the graph of wire Q is steeper, it means the gradient of the conductivity of wire Q is higher. If we are saying gradient is conductivity and wire Q has a steeper line, right? So if line is steeper, it means the gradient is higher. Okay, so here this is less steep, so a higher gradient, less gradient. So that means higher conductivity and less conductivity. So there you have your answer. So which wire, P or Q, is a better conductor? The answer is Q, the one with the higher conductivity. Okay, so it says explain your answer. So what we must do, we must say that the gradient of the line, okay, gradient of the line is conductivity. So gradient of the line represent what physical quantity is represented by the gradient. This is going to be conductivity. But we see that gradient of wire Q is greater than gradient of P. So what does that mean? If gradient of wire Q is greater than a gradient of wire P, we can therefore conclude now that Q has higher conductivity, and therefore Q is a better conductor. Thank you. This takes us to the end of the lesson.